I mean, there's no downside to signing up to come to the code class. You don't ever have to come.
Or you could just not register.
Well, and actually next quarter, it's not even going to be something you can sign up for in Schedule Builder. So it's
Okay.
just going to be, I add you to campus. So you should all just let me add you to campus. You don't have to. But I hope you did.
I know about different things.
I mean, yeah, I would say you should talk to the professor, but that's unlikely to get you much traction, really.
Because I would have waitlisted for it my first pass time,
Right.
but I wanted to register for stats backup. But then I was over the unit limit by 2 units.
Mm-hmm.
And so I was like, I can't get rid of any of these other classes because I need to take them. And so I was like, I'll just wait this in past 2.
Right,
Well,
yeah.
there's not like 100 people on it.
Well, I suppose the upside, although it's not really great, but there's certainly the possibility that some people who are signed up for it are not going to pass 16B and will not be able to take it. That's not something I like to say, but it's true.
Right on there, down the phone.
Yeah, Maya, we can look at a problem either like that or actually that. Let's see here. I know it doesn't feel good, but like that's the reality. Hello. Who? Probably.
They're not willing to. Yeah. It's good. Is he striking? Yeah.
I'll be down there after class as usual on Monday, Wednesday. Let's see. Chat. We're going in just a second. Come on, what's your problem? I assume you'll still have your test on Friday. Like it hasn't been canceled or postponed. Yeah, that's what I figured. Sure, but
I agree all of them.
yeah, that's well. So not all. It's I don't know. Like it's possible that not all of her TAs are striking.
But she only has 2. And
Sure.
I haven't been getting the email and
Yeah.
sounds,
It's likely.
So.
Yeah, I mean, it's the thing people do. It's kind of the deal sometimes. I've definitely.
Isn't the entire thing?
What's that?
Response? There's no multiple choice.
Sure. Yeah.
If you're like, girl, it's gonna take you forever.
Right. And so someone else was asking this question to my colleague, and it seemed like a good point. Will there be partial credit? And the odds are there might be less partial credit given if your teacher is the one grading all of them. So just not that that should really change how you approach taking the test, I think, but it's something to be potentially aware of. You should still show your work, though. That is my opinion, and I am sticking with it. Let's see here. I feel like I'm forgetting something. I think I got it there. Okay. I guess I need pens. Pens would be good. Let's grab this and this. Oh, interesting. Okay. Sure, that problem 6 isn't too bad. We'll get to there eventually, Maya, but not right away because we should talk about all the all the improper integral stuff. All right, we should get going. It's 2:11. Going. Come on. Come on in. All right. So improper integrals, we talked about just very briefly at the end of last class. We'll continue on today. There's two types. The type that have an infinity or the type that have a place for the function's undefined. And I guess you could have both those types in one integral as well. So just to kind of point out the different types. No. So types of improper integrals. There's, say, you're something with an infinity. So like, the integral from 1 to infinity of 1 over x cubed, for example. We're not necessarily going to do all these. I'm just showing you that this is improper. That looks kind of, that could be, does that look clear to you? No. Let's there's supposed to be like an autofocus here. There we go. Okay then. All right. That's good. Okay, cool. So this one is improper because there's an infinity. So we have to rewrite it as the limit as t approaches infinity of the integral from 1 to t of 1 over x cubed. In a similar way, this integral from negative infinity to infinity of, let's say, x over x squared plus 1 is also improper for the same sort of reason. You've got infinities. Now, if you have both an infinity and a minus infinity, you can't, here's what I would say. You can't ever deal with two problems at once, at least when they're improper. You can only deal with one improper problem at a time, and each infinity is its own issue to deal with. So we have to break this up as two integrals. You can break it up anywhere you want. The standard choice is to pick 0. So I'm going to break this up as the integral from negative infinity to 0. These pens. Of x over x squared plus 1 plus the integral from 0 to infinity of x over x squared plus 1. And we'll talk more about this example in a second. So those are the kind of two varieties, not the two varieties. This is the one variety with infinity. Basically, infinity is always an issue. So I should say then you would write this as the limit as t approaches negative infinity of the integral from t to 0 of x over x squared plus 1. And just to use a different variable, although you could also use t, but I'm going to use something else. The limit as z goes to infinity of the integral from 0 to z of x over x squared plus 1. And then you'd have to deal with each of these separately. Now, two different things can happen. Well, I should say, two different questions can be asked. One question I could ask is, does this converge or diverge? And the answer is going to be that it diverges. The other question I could ask is, does this converge or diverge? And if it diverges, does it diverge to infinity, negative infinity, or we can't tell? Which is sometimes what your homework questions ask. I doubt you will see that type of question on your actual exam. If you're, not that you couldn't, you could, but my guess would be if you're doing improper integrals, you're either going to see stuff that converges or diverges, and you're probably not going to be asked if it diverges to infinity or to negative infinity, or we can't tell. That said, let's actually do this one. So if I was doing this particular improper integral, I would not write all this stuff down when I actually did the antiderivative. I would sneak off to the side here and say, if I'm going to do just the indefinite integral of x over x squared plus 1, I'm going to need to do a u sub. I really don't like doing u subs when I have all this other garbage along with it. So I'm just going to do the antiderivative off to the side so I don't have to carry the limit and the limits of integration along with my work. So that's going to be, I'm going to do u equal to x squared plus 1. Du is 2x dx. I'm going to do this my way because it's easier. Du divided by 2 equals x dx. So I'm just going to replace this x dx with du divided by 2 and rewrite this as 1 over u times du divided by 2. Integral of 1 over u is natural log of the absolute value of u. So this ends up being 1/2 natural log of the absolute value of x squared plus 1. Yeah, we could drop an absolute value if we wanted to, but it's not really necessary to do that, so we're not going to bother. So then, if I was doing this portion first, I'd say, okay, that's going to be the limit as t goes to negative infinity of, well, the integral of this is 1/2 the natural log of the absolute value of x squared plus 1 from t to 0, and then I just plug in the t and the 0. And the limit is t goes to minus infinity of 1/2 the natural log of 0 squared plus 1, which is 1, minus the natural log, sorry, 1/2 the natural log of t squared plus 1. I don't need the absolute value, but I should have written them properly. Fine. So now is where you actually have to take the limit. So as t goes to negative infinity, t squared is positive infinity, add 1, still infinity, and the natural log of infinity goes to infinity. So this definitely diverges. So now here's where your homework question is going to dictate what you do next. If they're just asking if it converges or diverges, you're done. It diverges. If they're asking you if it diverges to infinity or negative infinity or we don't know, then you have to look at the other piece, which is unfortunate, but true. And I feel like I might have made I did make a mistake here. A small mistake, but an important one. That should actually diverge to negative infinity because it's minus all that stuff I just said was going to infinity. And it's 0 minus that, so I mean, it could be 1 minus it would still be negative. So I should point out this part does actually go to minus infinity. Okay, the other part, the work is the same. I'm just going to kind of skip a little bit and say I'm going to get down to the second stage here where it's going to be the limit as z goes to infinity. The integral of this is 1/2 natural log of the absolute x squared plus 1. By plugging z and then 0, I'm going to get 1/2 natural log of the absolute value of z squared plus 1 minus 1/2 natural log of the absolute value of 0 squared plus 1. That part is natural log of 1, which is 0. And this part here, as z goes to infinity, z squared goes to infinity, the natural log of infinity goes to infinity. So this is going to go to infinity. So what that means is that overall, this thing diverges, but we don't know what it diverges to. So definitely diverges, but but like the limit, we would say the limit does not exist. Because we have an indeterminate form. We have a negative infinity plus infinity, which is now sadly, and it's a little sad, if you looked at this, and in fact, it's actually extremely sad because some teachers incorrectly would say that this integral is 0, specifically because it's an odd function. So I want to point out that x over x squared plus 1 is an odd function. It looks like this. If you plug in 1, you get 1/2. -1, -1. It has this shape here. And it does have the symmetry of an odd function. Some people like to make the incorrect argument that these areas cancel each other out and you get 0. It's wrong. Because this part diverges to infinity, this part diverges to negative infinity, and even though they look like they should be the same and cancel out, we can't say that. So whether or not they look the same or not, infinity plus negative infinity or infinity minus infinity is, we don't know. So again, I don't think you'll actually see this sort of question on the test. I think if someone asked you this integral, they would just be asking you to tell them if it converged or diverged. But on a homework question, they might be like, well, does it converge or diverge? And if it diverges, does it diverge to infinity, negative infinity, or we can't tell? The way I determined it diverged was by specifically, once I got the limit to be some sort of infinity, I was done. I knew it diverged. And that's actually always the case. So if you have to break up your integral into more than one piece, once one piece is divergent, the whole thing is divergent, because whatever you're adding on after that, you're either adding some finite number, which means the thing is still diverging to either plus or minus infinity, or you're adding on some infinite number, which means you're either doing infinity plus infinity, which is infinity, or you're doing infinity minus infinity, which is we don't know. But either way, once you get some small piece being infinite or negatively infinite, you're done. Well, maybe you're not done, but you can conclude divergence. There might still be more work to do, unfortunately. Yeah, cool. The other type of improper integral does not involve an infinity. It's one where the integrand, the function you're integrating, is undefined somewhere on the interval of integration. Lots of I words there. So, for example, the integral from 1 to 5 of 1 over the cube root of x minus 1. Oh, thanks. Appreciate it. So when you see an integral like this, your teacher, I would hope they would point out that it was improper, but they might not. So whenever you see integrals where you might have a place where it's undefined, you have to look for where it's undefined. This function, f of x equal to 1 over the cube root of x minus 1, is undefined at x equal to 1. Now, again, the wrong way to do this would just be to anti-differentiate and plug in your points and go along your way. But the right way to do this is to use a limit. So we're going to rewrite this as the limit as t approaches the problem. Right? It's always the problem point that we're replacing, whether it's infinity or whether it's 1 here, that's what has to get replaced. So we're doing the limit as t approaches 1 from the right, which we'll talk about in a second, of the integral from t to 5. And I would rewrite this as x minus 1 to the negative 1/3 power. Two things. Thing one, why from the right and not just approaching 1? Well, my interval is between 1 and 5. That's my interval. That's my AB. If I'm between 1 and 5, I'm definitely on the right side of 5. And we typically like to be specific about it. It doesn't matter so much for this function because the cube root is defined on either side of a positive or negative thing. But if it was a square root, it would really matter because you can't take the square root of a negative number. And if you approach 5 from the wrong side, your inputs are negative. So I would encourage you to be specific about which side you're approaching your non-infinity problem points from. Basically, here's the gist. If it's the lower limit, you're always approaching it from the right because you're bigger than it. If it's the upper limit, you're always approaching it from the left because it's the you're left of it because it's I was saying good words and then they went away because it's the upper limit and you're to the left of it. So here we integrate. I'm not going to bother doing a u substitution. You could do u equals x minus 1. I think it's pretty straightforward though. My integral is going to be x minus 1 to the negative 1/3 plus 1 is positive 2/3. Dividing by 2/3 is the same as multiplying by 3/2. From t5, we keep doing the integral. We don't deal with this actual limit until the very end. So I plug in my 5. I get 3/2 times 5 minus 1 to the 2. That was a poor choice, James. Oh well. It's gonna be a gross number. That's fine. Sometimes that happens. I meant for it to be nice, but okay. And then minus 3/2 times t minus 1 to the 2/3 power. This part is going to be some number. It doesn't really matter. It's 3/2 times 4 to the 2/3 power, which does not simplify nicely. You could make it the cube root of 16 if you really wanted to, but it's not really important. Now, here's where we have to be careful. If t goes to 1, 1 minus 1 is 0, and 0 to the 2/3 power is 0, so we're good. Well, we'll look at another example. We'll see why I have to be careful. So then our answer here would just be 3/2 times 4 to the 2/3. You might need to actually write the words that the integral converges to that value. But that is typically understood that if your integral ends up equaling some finite number, we say that it converges to that finite number. Whether it's something gross like 3/2 times 4 to the 2/3 or something nicer like 5. Okay. Let's look at another example similar to this. We can probably make it fit, yeah. Let's say we want to do the integral from, let's make the numbers a little bit nicer, James. From 2 to, sorry, I was trying to make nice numbers. From 2 to 11 of 6 over the square root of, I was going to go that other way. Actually, let's do that instead. I'm gonna have to think for a minute here. Sorry, I have to think and it's not happening. Yeah, sure, let's do that. Of 11 minus x. Cool, that should work. Hopefully it's not obvious to see that 11 is the problem. The 11 is definitely the problem, right? Oh, I was gonna make this one. I don't like the choices I've made. I'm going to fix it by making it look terrible. I'm just going to rewrite it. Not this. We're going to do something slightly different, but it's going to be fine. Sorry, apologize. I wanted something else to happen. I forgot about that when I was writing the problem. Let's do 11 minus x to the third power instead. Sorry, I know it's terrible. Okay, so same idea. Whatever the problem is gets replaced with your dummy variable, either t or z or a or b, whatever you like to use. I think your teacher's using t, right? Okay. So we're gonna write this as the limit as t approaches 11 from the left or from the right? From the left. We're between 2 and 11, so we're definitely smaller than 11. Of the integral from 2 to t of 6 over 11 minus x cubed. If you like, and I might have done this, you can pull out the 6 and write it as 1 over 11 minus x cubed. I should have been a little bit better there. I would have definitely, if I was trying to save steps, written this as the limit as t approaches 11 from the left of 6 times the integral from 2 to t of 11 minus x to the negative third power. Personally, I also think this is something we can integrate without doing the use of. So I'll remind you that when you, okay, so if this was u to the negative third, we'd get u to the negative second over negative 2 when we integrate this. That coefficient of x is going to be, we're going to end up dividing by a -1 when we do that. Because if you let u equal 11 minus x, your du would equal minus dx, and you'd end up dividing by a -1. That's why we end up dividing by that coefficient of x. So I think, and again, if you want to see it, I'm happy to show it. Let me know. I think we can do this as the limit as t approaches 11 from the left of 6 times the integral of this is going to be 11 minus x to the -2 divided by -2 and a -1 for the coefficient of x there. Which is really like multiplying by -1, but it's division. From 2 to t, and then rewriting this just slightly, it's going to be the limit as t approaches 11 from the left. 6 divided by 2 is 3. So I have 3 times 11 minus t to the -2 minus 3 times 11 minus 2 to the -2. And here's where it's easy to get yourself in trouble. If you plug in 11, what's 11 minus 11? What's 0 to the -2 power?
3 over 0 squared.
Right. Oh yeah, I was ignoring the 3. Right. So when you have 0 to a negative power, you're dividing by 0. So I would encourage you, if it's not easy to see that for you, and it's not always easy for me to see it, I really like my powers to be positive. So I would totally rewrite this as the limit as t approaches 11 from the left of 3 over 11 minus t, that's a t squared, minus 3 over 9 squared. And then when I plug in 11 for t, 11 minus 11 is 0, 0 squared is 0, and 3 divided by 0 is undefined. Specifically here, we're going to positive infinity since it's 3 over a positive number. This is going to positive infinity minus 3 over 81, which I don't care about because it's just a finite number. We're subtracting from infinity, doesn't change anything. So we would say this diverges, and if we were asked to what, we would say diverges to infinity. So it's perfectly fine to get a 0, but be careful. In the previous problem, 0 to a positive power, sorry, right there, 1 minus 1 to the positive 2/3, totally worked out to be 0. But 0 to a negative power is undefined. So just be aware of that. Yeah. Cool. Questions so far before yeah.
What is next to it's 3 over 9 squared or
Yeah, that's 3 over 9 squared because I rewrote. So 11 minus 2 is 9, and then 9 to the -2 is 1 over 9 squared. That's 3 over 9 squared. Yeah, but again, so really, I'm right. This part's going to infinity, and I could write minus 3 over 81, but then infinity minus 3 over 81 is still infinity. Yeah. Why is it infinity? Good question. So what's happening is I'm approaching 11 from the left, although it doesn't really matter what side in this particular problem. So right here, and I know that's maybe hard to see because my writing sometimes sucks. That's a t. And so if I plug in 11 for t, 11 minus 11 is 0. 0 squared is still 0, but it's definitely for sure positive, even if it was negative before, which it wasn't. So I've got a very, very, very tiny positive number. 3 divided by a very, very small number is going to be super large. Let me show you what I mean. Let's say we plugged in the numbers super close to 0, like, I don't know. Sorry, super close to 11, like 10.999999999. If I plug that in, here's what I've got. 3 divided by 11 minus 10 point. Okay, I'm not gonna say that many nines. Let's say that many nines. Squared. That's gonna be super huge because it's gonna be 3 divided by 0.0001 squared, which is 3 divided by 0. Lots of zeros. I think it's this many zeros. I'm not exactly sure. It doesn't really matter. But when I divide by, I don't know, 100 millionth, that's like multiplying by 100 million. So this ends up being 3 times. Ignore the mistakes in the zeros, please. So when you divide by a super duper small number, it ends up making your fraction blow up. On the inverse side, when you divide by a super large number, it makes your fraction scrunch down. Because you're dividing, like if I was doing 3 divided by infinity, I'm dividing 3 up into a bajillion little pieces. Whereas I'm dividing 3 by something super small, it is growing super large because I'm making its denominator very, very small. Does that answer your question? Okay. So the general kind of intuition should be if your denominator is big, your fraction is small. And if your denominator is small, your fraction is big. I agree.
So how do you go from the limit of t and push them for that 6 over t to 2? I go from 11 minus x to the negative 3 to 11x to the negative 2 over negative 2 times 1.
So I did a couple things at once. So from this step to this step, I said the 6 divided by the 2 was 3. There and there. And then I plugged in my limits of integration. So instead of having 11 minus x to the negative second, I had 11 minus t to the negative second. Instead of having 11 minus x to the negative second, I had 11 minus 2 to the negative second.
Well, what about step 4? Like, how do you get?
Oh, from here to here? So that's the step I kind of hand waved at, but I can totally talk about that. So from there to there, I did the u substitution without, what I did was what I like to call a mini u substitution. So when we were doing this integral of 11 minus x to the negative third dx times 6, I just said it's going to be 6 times 11 minus x to the negative 3 plus 1 divided by negative 3 plus 1. And then I also knew that I had to divide by a negative 1 because there's a coefficient of negative 1 on the x there. It's the same sort of reasoning that we used to say that the integral of e to the 3x is e to the 3x. Right, I was going to say divided by 3, but yes, times 1/3 divided by 3. Same idea. Whenever you integrate something and you just have a multiple of x, you could do the long u substitution, or you could be like, well, if it's just a multiple of x, I can just divide by whatever the coefficient of x is. But if you want to do the u sub here, the u sub here would be to, let's say, let u equal 11 minus x. Du is equal to negative 1 times dx, so negative du is positive dx, and this becomes 6 times the integral of u to the negative third times a negative du. And then that's going to be negative 6u to the negative second over negative 2, which ends up equaling exactly that. So I was just taking a shortcut. You're welcome. Which should be a totally legit shortcut for you to take on the exam. Like, I feel like that's a totally fine thing for you to do, unless your teacher says it's not, but I don't think that's the case. Sorry, I'm off here 1 second. Come on. I think it's so off with this here. Okay. Let's see. Oh, darn it, I broke my pen. The only one that was working. Okay, got my pen. We'll just use red. Red always works. We never use red. Okay. So the other thing to be aware of with these kinds, so again, infinity is a problem. and then places where the function is undefined is a problem. So one other type of thing to be aware of is sometimes your problem point is not one of the endpoints. Your problem, say for example, if I want to do the integral from, I don't know, 1 to 5 of 1 over x minus 2. Sure, x minus 2, that's fine. Is that fine? Sure, why not? Now let's do 1 over x minus 2 cubed. To the 4th. There's a problem, and the problem is 2. But it's not one of the endpoints, so we have to break this integral up at the place that's the problem. So we're going to write this as the integral from 1 to 2 of, let's be smart, x minus 2 to the negative 4th dx, plus the integral from 2 to 5 of x minus 2 to the negative 4th dx. And then we have to deal with each of these separately. So I'm going to deal with this one first. So the integral from 1 to 2 is going to be of x minus 2 to the negative 4th is going to be the limit as t approaches 2 from the left, of the integral from 1 to t of x minus 2 to the negative 4th. Then we integrate. Again, you could do a u sub here, but you really don't need to, especially when it's just x plus or minus something. The integral of x minus 2 to the negative 4th is going to be, sorry, so I'm going to write the limit. X minus 2 to the negative 4th is going to be x minus 2 to the negative 4 plus 1 divided by negative 4 plus 1. Don't need a plus t. We plug in elements of integration. Now, again, this is a place where I would encourage you to write it in a way so that you can have a positive exponent. To me, that's just easier to see. So this is going to be equal to the limit as t goes to 2 from the left of negative 1 over 3 times x minus 2 to the third from 1 to t. And then we plug in elements of integration. Limit as t approaches 2 from the left, negative 1 over 3 times t minus 2 cubed minus negative 1 over 3 times 1 minus 2 cubed. Gross. So then we can see that we're going to get some sort of infinity, because when you plug in t equals 2, you're going to get 2 minus 2, which is 0. And you're dividing by 0, which means you're blowing up to infinity. Now we do, if we're asked which way it diverges, we do have to be careful to see what kind of infinity we're going to get. So if I'm plugging in a number slightly smaller than 2, that means I have number smaller than 2 minus 2 is negative. Negative number cubed is still negative. Times 3 is still negative, but then there's a negative out here, which is going to turn into a positive infinity. We're not done. We're half done. So at this juncture, we know the whole thing diverges. And it's either going to diverge to infinity or we don't know. Negative infinity is not an option at this point. Either going to be infinity or we don't know. And it wholly depends on what this other half is going to do. Here's a nice thing about having to do the other half. You've already done the first half, you know how most of the work is going to look. You could simply, I feel like I can steal this part up here. If I'm going to do this part here, I'm going to write the integral from 2 to 5 of x minus 2 to the negative 4th dx as the limit as t approaches 2 from the right of the integral from t to 5 of x minus 2 to the negative 4th. But then I should really just jump to saying, okay, well, I know the integral is going to be x minus 2 to the negative, or really this one, negative 1 over 3 times x minus 2 cubed. So I get the limit as t approaches 2 from the right of negative 1 over 3 times x minus 2 cubed from t to 5. And then we plug in, we get the limit as t approaches 2 from the right, negative 1 over 3 times 5 minus 2 cubed minus negative 1 over 3 times t minus 2 cubed. Okay, so then if I plug in a number slightly larger than 2, I'm totally ignoring this. This finite term here doesn't matter really at all. But if I plug in a number slightly bigger than 2, that minus 2 is positive. Positive number cubed is still positive. Times 3 is still positive. And then the negative of a negative is still positive. So the whole thing is going to be also positive infinity. So this integral from 1 to 5 of 1 over x minus 2 to the 4th dx does diverge, and it diverges to infinity. which again, probably would be asked on the homework, but probably not. on the exam. I don't think anyway. I would never ask that question. Questions about this? Oh, I know what it was. Okay. We're close to the question you asked, Maya, but let me do one more thing. Yeah. Sorry. Sure. Let's do the integral from. Yeah, let's go back to some infinity stuff. Integral from negative infinity to infinity of e to the negative 6x dx. Got to break it up. Anywhere you want. 0 is almost always the choice. Someone could give you, I don't think I saw any on here, but let me double check now that I'm looking. Someone could give you something extra crappy that was infinity and undefined somewhere. Ooh, yeah, like problem 3. Problem 3 is extra crappy. We might have to look at that one, but we'll look at this one first. So here I'm breaking this up at 0 because that's the typical choice. But really, you could make any choice. Okay. So if you're just asked if the thing converges or diverges, you should try to look for the piece you think might diverge. So I know that when I integrate e to the negative 6x, I'm going to essentially get e to the negative 6x. Which infinity is going to make this thing diverge if I plug it in? Is it going to be e to the negative 6 times negative infinity or e to the negative 6 times positive infinity? Negative or positive? I think it's going to be the negative one because negative 6 times negative infinity is positive infinity, and e to a big number is a big number. Whereas e to a negatively big number is, I'm not going to think about it right now, although I know it's 0. Because I know the graph of e to the negative 6x looks like that. That's what I'm really thinking about. Sorry if you can't see that over there. Oh, I didn't turn on my picture. Sorry. Oh, wait, did I not? I suck. Sorry, Maya. Not that it's that important to see me, but like, I apologize. I like being on camera. What can I say? Not really, but you know. Okay. So, let's see. There's a question here. We happen to a problem on the exam. How do you know if we need to use this process over something else? Well, so what I would say is this process is wholly divorced from U sub or partial fractions. You could have to do this and also do any of the methods of integration we've learned. This is not a method of integration. This is a thing we have to do if we see problem limits of integration. So you might, in fact, there are problems. So looking at your homework, I see that specifically problem 4, you need to do a U substitution in addition to the integration, the improper integral. Problem 5 as well. I don't know about problem 7. So sometimes you have to do a U sub in addition, which we already did, right? The problem we did back here, right? This first problem we actually did, the integral from negative infinity to infinity of x over x squared plus 1. That one, we did a U sub to actually do the integral, and then we still did all the improper stuff over here. It's typically not very nice to have one with partial fractions with this, but it can come up. In fact, I might show you one if we have time, because it's often a popular test question. But let's see here. So if I was doing this one, I would look at this part first and say, okay, I'm going to do the limit as t approaches negative infinity of integral from t to 0 of e to the negative 6x dx. We integrate. Now, technically, you could do a U sub right here. I'm not going to do it because it's a mini U sub, but U sub is the method of integration we are kind of espousing here, although we're kind of not because we're just saying we know how to do it. Integral of e to the negative 6x is e to the negative 6x divided by negative 6 from t to 0. And then you get the limit as t goes to negative infinity of e to the 0 over negative 6 minus e to the negative 6t over negative 6. And then we plug in t going to negative, or I guess not plugging in is the wrong thing to say. We think about what's happening as t goes to negative infinity. So if t is going to negative infinity, negative 6 times negative infinity is positive infinity, and e to a big number is a big number. So this here is going to go to infinity. So we're end up getting negative 1/6, which you don't really care about, minus is plus infinity over 6 if you really want, which is going to be infinity. Now, if I were just asked about convergence or divergence, I'd say, stop, I'm done, it diverges. If I had to say in which way it diverged, I would have to look at the other half of it. So the other half, if I do the integral from 0 to infinity of e to the negative 6x dx, I'm going to try and do as little work as possible. I'm going to say, well, that's going to be the limit as t goes to infinity. And I already know the integral of this is e to the negative 6x over negative 6. And my limits of integration would be 0 to t instead of 0 to infinity. So then plugging in, you get the limit as t goes to infinity of e to the negative 6t over negative 6 minus e to the negative 0 over negative 6. Now, some people, like myself, sometimes struggle when the power is negative. I just don't love a negative power. It's harder for me to make sense of exactly what's happening. With experience, you'll come to see typically that e to a negative big power or 2 to a negative big power does tend towards 0. You can think about the graph, but the easier algebraic way of getting there is to do the following. Make the manipulation so that whatever your exponent is, it's going to positive infinity. If it's a choice between negative or positive infinity, meaning this thing in the top here going to negative 6 times infinity, bring it down to the bottom, change the sign. So rewrite this as the limit as t goes to infinity of 1 over negative 6 times e to the positive 6t minus or plus, I guess, 1/6. That's what I would suggest, because then it's easy to see what's happening. T goes to infinity, 6 times infinity is infinity, e to the infinity is infinity. 1 divided by infinity is small. This part here is going to 0. So this whole part here is going to 0 plus 1/6, which is 1/6. Which means this portion happens to converge, but the overall integral diverges, and it diverges to infinity because infinity plus 1/6 is still infinity. So if one piece diverges, the whole thing diverges. If one piece converges, like if you've done this piece first, you would definitely have to do the other piece to see if the whole thing diverged or converged. So that's why I say if you're just being asked if it's convergent or divergent, it's good to look at the piece that you think might be divergent if you have to break it up into multiple pieces. Okay. Like there was something else I want to say here. Oh, I know what it's done. Okay. 2 questions for you guys. One, has your teacher said anything about using L'Hopital's rule? Okay, I didn't think so. I just want to double check. L'Hopital's rule is great, and it does come up in some of these problems on occasion. Oh, actually, let me see here. No, that should be fine. I don't think it's coming up in any of your homework questions, which is good. So let's look at. Yeah, we'll look at 6, and then maybe one thing I'm going to do, and then yeah, okay, we'll see. So here's problem 6 from your homework. Let R be the region bounded above by the graph of y equals e to the negative 4x. Which again, if it's e to a positive thing times x, it's increasing from left to right. If it's e to the negative 4x, it's decreasing from left to right. Looks vaguely like this. 0.01. Bounded above, so that's our upper bound. It's bounded below by the x-axis and bounded on the left by the y-axis. Now, the point of this question is that the boundaries they have given you mean we have to do an improper integral because we have to go all the way to infinity because there is no right-hand bound. We have an upper bound, we have a lower bound, we have the left bound, but these don't cross each other ever, so there is no right boundary. They want us to find both the area, which is going to be the integral from 0 to infinity of e to the negative 4x dx. Sorry, oops, that's an x. That's terrible, James. I apologize profusely for the grossness I'm writing there. You can that's an e to the negative 4x dx. And then they're also asking us to find the volume of the solid generated by revolving this around the x-axis. To revolve this, the volume is going to be the integral from 0 to infinity of pi times our radius squared. Which I would strongly recommend simplifying. This simplifies as pi times the integral from 0 to infinity of e to the negative 4x squared is e to the negative 8x. EX. And hopefully, from the work we just did, you can convince yourself that that's going to end up converging. Because the integral we just did, whereas integral from 0 to infinity of e to the negative 6x, just that right half of it was convergent. Both of these should also end up converging. Let's do, I don't know, let's do the second one. So for the volume, we're going to do pi times y, okay, fine. Pi times the integral from 0 to infinity of e to the negative 8x dx. And that's going to equal the limit as t goes to infinity of the integral from 0 to t of e to the negative 8x dx. And that's going to be the limit. You got to write the limit every time. It's kind of annoying, but that's life. Integral of e to the, oh, don't forget the pi. It's easy to forget the pi. Almost Thanksgiving, don't forget the pi. Right? You can remember that way, maybe. Integral, that's that from 0 to t, plug in your limits of integration. So I've got pi times e to the negative 8t over negative 8 minus pi times e to the 0 over negative 8. And then you can either do what I like to do and say, I'm going to rewrite this so my power is positive. And I should really stress, I don't need the coefficient to be positive. I need that when I'm plugging in whatever t is going to, the power ends up being positive. That's why in the previous problem, no, it's not a good example of that. That's why in the previous problem, like this right here, I left this as an e to the negative 6 x or e to the negative 6t because when I plugged in negative infinity, the power was positive. So I'm not saying you need a positive sign, you need an overall positive result after you think about plugging in what t is going to. Okay. Here, on the other hand, though, I would write this as the limit as t goes to infinity of negative pi over 8 e to the 8t plus pi over 8. As t goes to infinity, e to the 8t gets infinitely large, and dividing by it gets infinitesimally small. So you're just left with pi over 8. So the volume of this infinite shape has pi over 8 cubic units. You could do a similar thing for this one. I don't want to because I want to talk about something else. But if you do this integral here, you should end up getting, I believe, a finite area of 1/4. Yeah, that seems right. 1/4. Yeah, because we don't have the pi like we had here. So why we need to do this process? So we did a few examples like that. So if you look back at the previous stuff, Matt. But the reason we need to do this process, the limits of integration are definite, is sometimes the function's undefined. So let me just point out. If we weren't careful, you could get something totally wrong. If I did the integral from, say, -1 to 2 of 1 over x squared, if I wasn't being very careful with this, I'd be like, oh, well, I know how to integrate that. That's going to be the integral from -1 to 2 of x to the negative second. This is wrong. Don't write this down. X to the -1 over -1 from -1 to 2, which is -1 over x from -1 to 2, which is -1/2 minus, sorry, brain, minus, oh my gosh, I'm plugging in -1 over -1. Okay, I think that's right. Does that seem right? I hope. That's going to be -1/2 minus 1, which is -3/2. Seem good? Well, no, it shouldn't seem good. It seemed like I did the wrong work. Yeah, but definitely not right. Because check out my graph. 1 over x squared looks like this. And no matter what, if I'm finding the area under it, that area should be positive. And from -1 to 2, that area is certainly not -3/2. So the problem here is that when your function's undefined somewhere, either in between your endpoints or at one of your endpoints, you have the possibility of getting an infinite amount of area. And that's what's actually happening here. This integral definitely diverges to infinity because your area is infinite. Okay. Cool. So let's look at, there's one problem on here that I just glanced at that didn't seem specifically obvious to me. So I just wanted to address it. The integral from -infinity to 0 of 3 cosine of 6x. Which seems weird. in my opinion, but fine. Fortunately, cosine's defined everywhere. It's a nice, continuous function that has a domain that's everything. But we've got an infinity, so we have to deal with it. The limit is t goes to negative infinity of the integral from t to 0 of 3 cosine of 6x. And I'm going to say, just like before, you could do a u substitution here and let u equal 6x, but you shouldn't. You should just do the antiderivative by saying, I know I'm going to have to divide by the coefficient of x, since we just have a multiple of x. If it was 6x squared, it'd be a totally different story. You'd have to do something completely different. But just for 6x, you'd be like, oh, that's going to be 3 sine of 6x. It is positive sine, right? Because derivative sine is cosine, divided by the coefficient of x, 6. Because of the chain rule. From t to 0, and then we plug in, and we get 3 over 6 is 1/2, so I have 1/2 sine of 6 times 0 minus 1/2 sine of 6 times t. So now you have to ask yourself the question, okay, well, sine of 0 is 0. But what happens as t goes to negative infinity of the sine function? Well, what's the sine function do? This, right? And it doesn't stop doing this. So you're stuck. It's oscillating. It doesn't have a limit that converges to one particular value. It is divergent. And it is divergent in the very not existing sort of way. Right? In fact, it's not even diverging necessarily to infinity or negative infinity. It's just divergent, and we can't really say anything more. So this limit does not exist. And if the limit doesn't exist, the integral is divergent. How much time have I got? Not a lot. Okay, so let me just do it real quick. I was gonna look at you. Just curious, if you have any of you looked at the practice tests? Were there any partial fractions questions that were improper? Yeah, like maybe, probably not.
I think there's only one.
Oh yeah,
No, sorry, one.
sure. Yeah, there's something that's kind of neat that I would show you, but I really don't think it's worth your brain capacity right now. Like, it's certainly worth learning. I think it's neat, but I don't think it's something you're actually going to see. So I don't want to burden you with that. Yeah. So what I would say is you could see something like the following. Oh, I know what it was. It was, yeah, let's go back and look at terrible problem 3 or something similar to it. Which, I know it's fine. So the integral from sure, let's make it less terrible then. From 1/3 to infinity of 1 over the square root of 3x minus 1. This problem is doubly terrible because infinity is always a problem. And what else is a problem here? 1/3. Now, they were slightly nice and they didn't make it from 0 to infinity. Well, it was 0 wouldn't work because it's the square root, but they could make it so you had a problem point in the middle of something with an infinity, and then you have to break it up and then break it up again. It should be super awful. Probably not going to see that. So, but we definitely have to break this one up at pick your poison. I'm going to pick. I might pick a number that's easy to actually plug in and get a square root of. So no, that's dumb, James. I'm trying to think of a number that works nicely. There's not really one because you're subtracting one, and that doesn't really work. Yeah, don't try and be fancy. Just pick something like 1. I wanted to be fancy, but I shouldn't be. So we do this. And now we're going to ask ourselves, which one do we think is going to diverge? If any of them, right? It could be that neither of them diverge. But here's what I'm thinking about. I've essentially got 1 over the square root of x. Or in other words, I've essentially, although not exactly, I've got x to the negative 1/2. And when I integrate x to the negative 1/2, I get x to the positive 1/2, or I get the square root of x essentially, right? Again, I'm a little hand wavy here because I'm not trying to be super precise yet. So if I have the square root of x can I plug in 1/3 and 1 to the square root of x and get nice real results? Totally. I mean, square root of 1/3 is not like nice, but it's real. On the other hand, if I get the square root of x over here and I plug in infinity, what's the square root of infinity? Still infinity. So of the two, I would guess that one's more likely to diverge, and I would look at doing that one first. If I'm just trying to tell if it's convergent or divergent. And that's what's going to happen. You're going to get the limit as t goes to infinity of the integral from 1 to t. I'm going to rewrite this as 3x minus 1 to the negative 1/2. I'm going to do this fast because I know we're out of time. This is going to be the limit as t goes to infinity of, when I integrate this, I get 3x minus 1 to the positive 1/2 divided by positive 1/2. Also divided by 3 because of the 3x from 1 to t. And then we do the limit as t goes to infinity of 2/3 times 3t minus 1 to the 1/2 minus 2/3 times 3 times 1 minus 1 to the 1/2. And then as t goes to infinity, infinity to the 1/2 power, this is going to go to infinity, which means we're going to get infinity, which means it's going to diverge. I will point out, just for your knowledge, this part does converge. You should do it on your own. This part does diverge. So overall, the whole thing diverges, which is why I'm not worried about checking this other part. And I guess if you want to do all the work, this part diverges to infinity, this part converges to a finite number, and infinity plus finite number is still infinity, so the whole thing diverges to infinity. Okay. For those of you who have the test before our class on Friday, good luck. For those of you who have the test after our class on Friday, I'll see you on Friday and we'll talk and we'll do testy things. Whatever you want. We can look at practice exams or other stuff. You should come with questions if you're coming on Friday. No one is required to come on Friday. Everyone will get marked present. Make sure you fill out the attendance form if you haven't already. Here it is again if you want to see it. And oh yeah, I said I would post. I meant to and I didn't. I'm sorry, I apologize. I will find an older video of me doing a midterm 2 kind of review that you can look at if you care to. I'll post that on Canvas as well. Yeah. All right. I'll see you all, or I won't see you all on Friday, but either way, good luck on your midterm. You're welcome.
Right, y'all. Good luck. Good luck Friday.
And I'll be over and dropping. Are you two, are either of you taking 16C next quarter? You're not? Are you registered for it? Not yet. Are you on the wait list?